Okay, so for a generalized statement on my experience of this subject, I definitely learned a lot, especially when it comes to control systems, feedback systems, and such. So it's really a learning experience throughout the semester with this subject. So starting off with laboratory one, here we were still first introduced to block diagrams. So for instance, we have the series block diagram, which would constitute multiplication, and we have the parallel one, which would constitute addition, and we're also learning more about feedback systems. And from these, we were also introduced to the concept of the transfer function and how the block diagram for this transfer function came to be. And for the second laboratory, we were learning more about Simulink and Simscape. So basically, a Simulink uses signal blocks, and these blocks are more heavy towards mathematical models. However, Simscape, on the other hand, heavily rely more on physical or real life applications such as electrical systems and mechanical systems. For the third activity, here we advanced our ideas on transfer function by applying differential equations. And here we were also introduced to the concept of zeros and poles, and we were also introduced to the concept of the damping of a waveform. So I believe we have four, which should be the critically damped, underdamped, undamped, and overdamped. So moving on to the fourth activity, here we were also taking into consideration open loop function, which eventually led us to the topic of stability. So once again, when we talk about stability, it would be stable if the poles would be at the left, and otherwise, if there was a pole at the right, then that would deem the system unstable. And for number five, here, we were provided an underdamped waveform, and we obtained parameters such as the natural frequency, damping frequency, damping ratio, peak time, overshoot, and of course settling time. So we were introduced to these parameters, and we solved equations with varying poles and zeros. For the sixth activity, we evaluated different poles. So when you talk about evaluation, that would be our S sub 0, and implemented the root locus plot as well as the corresponding pole zero plot. So all with the gain of eventually obtaining our gain, which would be our K. For the seventh one, we solved for the root locus equation, starting with the closed loop poles. So of course, this solving process involves those parameters such as the overshoot and settling time, and eventually solved for the gain as well as the transfer function of these closed loop equations. And we were also introduced to MATLAB's CISO tool, which is an amazing tool because we can, adjust root locus plots or root locus equations. And for the last activity, we were then considering PI controllers and PD controllers as well as PID controllers. So basically, a PI controllers constitute the equation of Ki over S, so that would be our integral. And we also have the PD controller, which would constitute the equation KdS, so that would be our derivative. And we also have the PID system, which combines both. So speaking of PID system or a balancing system, we were also tasked to watch different videos on YouTube that discuss these systems. And it's really interesting to me because it's really amazing to know, how different feedback systems take into account errors over time to achieve a much more stable system. So basically, the major challenge I had throughout the semester was probably trying to understand more of the theoretical knowledge about it, because it's a really hard topic oftentimes to understand, especially the one dealing with root locus. However, I would like to thank the subject for really showing how we solve these equations via software tools like MATLAB, especially with the CISO tool and such. So they really gave me an idea on how these plots are made, how these equations are done. So yeah, it really gave me an idea, and it boosted me in solving equations, especially on the 3211 LEC. So thanks to the lab, it really solidified my understanding. And of course, I really want to thank our professor, Sir Ryan. Thank you, sir, for this semester. I know we've had some, or rather, there were some ups and downs, especially with what happened throughout my life recently. But I know you were very supportive throughout it, sir. So thank you so much, sir, especially, for everything that you have provided especially with our learnings and such. So once again, this was an amazing ECE 3211 lab experience, and I will definitely not forget it. Thank you so much.